We developed this little app to give you a conceptual explanation of what we mean by average rate of change for a function. So let's consider two cars, this Lamborghini and this Prius. So they're racing. Now let's watch the race. They start here and they're going to end about here. Okay, the Lamborghini pulls out. Oops, forgot something, has to go back to the pit stop. The Prius is just tooling along, no problem. But now the Lamborghini speeds up and in the end, bam, they tie. So what we're looking at here is an 8-second race. And now let's look at the graphs of the two. So I'm going to show the axes. So if we think of this as meters per second, what's going on with the Lamborghini, right? It starts up going faster, and therefore there is more. He's gone more distance since 0 than the Prius has. So you can see that his distance. And now if we show the Prius, see, at this point in time, the Prius is only this far away, probably about 1 meter away, whereas the Lamborghini is over 2 meters away. But as time increases, what happens? He starts going backwards, which means his distance is decreasing while the Prius is increasing its distance at a constant rate. What that means is for every second of time, the Prius is gaining the same number of feet or meters away from the start. What we see in the end is that they both end up having traveled for 8 seconds with a displacement of 6.4 meters. Or maybe you could say they both end up 6.4 meters away from 0. So what you can say is both ended up 6.4 meters in 8 seconds. They both ended up at the same distance away. So we say that the average rate is the rate that the Prius driver drove rather than the Lamborghini driver, because his speed varied throughout the trip, whereas the Prius the Prius speed stayed exactly the same. That's it. Hope it was helpful. Now we leave it to you to figure out what was that average rate of change.